So hi folks, welcome to SingDev Insights, and you're watching my daily Leetcode challenging series. And today is 5th of March, and today we will be solving our another problem with another excitement. And in this series, our target is not to just solve only the problem, but also make sure that you get through the process and get the way on how to approach a problem. And whenever you are in the interviews or even doing some online test or even working in the company, there we want to make sure that you are actually following the best practices. So this series will be covering that part also. So it is not just only about solving a problem, but also making sure how you can make that solution even effective as a software engineer, or whoever is watching this enthusiast, not a software engineer also. For them also it is going to be a great experience, and you will learn so many things. So let's dive into the problem before wasting any time. So today's problem is with the code 1750, and the problem name is minimum length of the string after deleting. So today's problem is with the code 1750, and the problem name is minimum length of the string after deleting semicolons. To be honest, I have seen like n number of problems with this naming, like minimum length of the string, like the questions how it's framed. Like I haven't told in my previous videos that, but I have done a lot of lead code. But don't and think like I have done 500 plus of problems. It's just like when everyone is in college, they do these questions to get into the company. So I was one of those candidates, and I know how this process goes. So at this moment, I want to make sure that you get it right, and you don't have to go to multiple websites or multiple articles just to understand the things. And yes, so let's continue with the problem. So this problem is currently being rated as medium. Yeah, that we'll figure out. So let's go into the problem. But before that, what will be the approach that we will be following? The first thing is we would be reading the question and getting the key information out and making sure we are writing it somewhere down. And right now I'm writing it in directly in the code editor, but what you could do is you can have a copy and a pen in which you can write it. So whatever you like and what is preferable on your end and at ease, you can follow that method. So first is reading the problem, second is going through the examples and understanding the problem more, and then reading the constraints that are given and making sure before approaching directly the problem, like if we are within the constraints, and then solving it, cracking it, and making it clean. Never forget the last part. Okay, so let's go with the question. Given a string S consisting only of characters A, B, and C, you are asked to apply the following algorithm on the string any number of times. Okay, we are just given we are given a string, and that is, for example, S. Characters are A, B, and C. And what is the algorithm that they are saying, that operation that we can do? We want to pick a non-empty prefix from the string S where all the characters in the prefix are equal. And in second step, a suffix, non-empty suffix from the string S where all characters in the suffix are equal. The prefix and suffix should not intersect at any index. The character from the prefix and suffix must be same. Delete both prefix and suffix, and after all of this operation, what is expected? Return the minimum length of S after performing the above operations any number of times, possibly 0. Okay, that 0 number of times also it is possible that. So this is the information, and there is some algorithm. I don't want to write everything here. We have some algorithm that they mentioned, like operations, and idea is to return. Okay, so as per question, what I understood is there is a string there, it contains only 3 characters as they mentioned, and the algorithm is we have a prefix where we are choosing a prefix where all the characters are equal, and then a suffix where all characters are equal, and making sure the characters, since this prefix is already having all elements equal, that's how we picked it up. And the same in the second. So if it is a series of A in the prefix, A is the character, and if it's A in the suffix, then A is the character. And we have a condition, the prefix and suffix characters must be same, so A should match A. from the prefix and suffix, and if these conditions all work, then we delete prefix and suffix. But one thing is, this window of prefix and this window of suffix should not intersect. So if a has which has been considered in prefix shouldn't be considered in the suffix. Okay, and then when we have performed this operation, it will give like after performing this operation, we will be having a lower string, like with a little like less length, and the same again we will be applying this operation and we'll be having a reduced length, and it goes in the continuous fashion. So let's check on with the first example. First example is CA. Let's select a prefix, that is C. Let's select a suffix, that is A. And they both are not equal. So obviously we can't perform any operation, and it will be zero operation, and the string still remains 2. So answer for this will be 2. Let's consider the second one. I think with second it will become more clear. We start with the prefix C. We check if A is also a part equals to C. Nah. So it prefix is only C. And then same in case of suffix. C and C are equal, so we can delete both of them. Now A and A goes, it also goes same for A and A. It goes also same for B and B, and A is also equals to A. So this becomes, I think the example that will make it more clear is should be somewhere here. Yeah, I think in the example 3, A B C C A B B A. We see prefix as AA. Since both our elements are equal, we take them, and we take the suffix also, and A is not equals to B, so we just take the A here and remove 2 A's because suffix and prefix are equal. Now here 2 B's, all the characters, because of the second condition, pick a non-empty suffix from the string where all characters in the suffix are equal. So we picked it up, and for the prefix also we picked, we remove, and we check the character in both of them are equal. So we delete B in the suffix, and in the prefix we delete B. Now we check if in CCA this condition works. Suffix is A and in prefix it's CC. The characters doesn't match, so it fails the condition number 4. So I think we can't perform this operation of deletion on this, and the string remains of the length 3. And I think that is what happening. And constraints are the length is like can go up to 10 to the power 5, and it just contains only these characters. As right now I'm not sure why this information specifically ABC is given, but I could think of an approach without considering this information. So let's first see what could be the possible cases. Like consider the same example. I think given this information characters is ABC, I could think of an approach without considering even this information that could be done within this that could be viable for this length. So if we have this length, then it means the expectation is n log n or n, something like that, time complexity. And how I know it, like you can check on to the some of the like Geeks for Geeks, or even some YouTube playlists that may be available to understand more on that time complexity, amortized time complexity. Like how do you actually find the time complexity when there is no clear indication. So that thing I learned in my when I was learned like in the college. So there was specifically a course in which they told like and dive deep in the time complexity, like how do you actually find out, even if it's not that very intuitive to see, like with the problem. Okay, if you are just looping and or you are doing sort and log n, but there are possibilities that it can go very high degree of complexity this when you do the time complexity. So I think going understanding that would be very helpful, because whenever you are in interviews, it is expected from you to know what you are doing affects how the system. So the code you write actually is the thing that you did, but how it's gonna impact the system is the thing that you should be aware of as an engineer. Because you can write a code thinking that it will work, but what if that machine doesn't support that complex operations, like you are applying nested loops, or like yeah, like it's a complex recursive operation. So you should be always making sure these be aware of your solution time complexity. So don't underestimate the time complexity. So yeah, moving on to the problem again. Here you might have question, why not just remove one, and why not remove just a here. But since it, I think in this case it doesn't gonna impact, because of the conditions that are given, that even if you just remove a and here a, then it would not be an optimal approach, because then the a and b cannot be equal, so it already fails, and we are interested in the minimum. So when we are interested in minimum, so we should make sure we consider all the elements that are equal in the prefix to be considered, not just a single element, because that may impact the minimum part of the problem. And as I see, we are going in the fashion of pick going from the left and right. It's a two pointer approach. So whoever is not aware why it's two pointer, we are picking up two indexes in this array, in this approach, and we are moving them around to actually, like, the problem may vary, but yeah, this is how the two pointer works. You actually pick, like most of the problems that you will be see, it will be like that. You are picking a left or right some pointers, and you are trying moving them around to achieve some kind of operation that may depend on the problem given. So I think it's clear what we want to do is we want to just follow the algorithm that has been mentioned and return the minimum length. Okay, so the language that I'm using for this problem is Java, and as I mentioned in my previous videos, this is the preferred language from my end, as I believe it gives me more understanding when I see something written very extensively. Because as you go with the Python or any other language, it's just like you can do some operations within one line, but for making someone understand, I would prefer to write in Java as compared to Python. So you don't need to go through the particular API docs to understand what this particular operation does, because in Java, it's actually written in the method name only in most of the times. So yeah, but it's a personal choice, but yes, we can, I'll be going with Java. So first of all, what do we want is, before going ahead, I'll just store the length of the string. That is the first thing that I always do. Now, since we want to iterate in a two pointer manner, like we want to move the prefix like from the left end and suffix from the right end, what we want to take is current start, that is the left part, and current end, that is the length of string minus 1. I think, yeah, that's what we want to do. And one thing that is obvious is we want to return is the length that we have reached when we move it around here, and when we move it around the place where we stop, when our conditions are not satisfying with the prefix and the suffix as per the given algorithm, we are going to stop, and we are just going to say, okay, the index from like start, the where we are at right now, and the end, this is the length, and that is what we want to return, and that is will be the minimum length if we do the operation by considering all the prefix that are available, all the characters in the prefix which are equal, not just taking one character. Even in spite there are many characters present in the prefix that can be like that are available, like they are same character, but the optimal would be to consider all the elements which are equal consecutively to achieve this condition of the minimum length. So we want in the end the length. This is what we are expecting. So this is just I have written the length, final length. Now we are moving around the, since we can't intersect, so it's obvious we have to have it as a greater condition. Just, and we also want to make sure that the character that is available in the end right now should match. They both should match, and when they don't match, we want to end the condition. So that's a key information. Now we want, as per this condition, the character should remain same. So let's consider like the current character. As you see, I'm naming the variables more like efficiently, not just a single character, so that enhances the readability, and I think that matters the most in the companies when you work there. Now here, let's first, just for reference, take current start as the character. Now what we want is to actually consider all the elements that are equal to be considered in the prefix. So that would mean if there are n elements, we want to have them. So we should be having some looping around it. And that would be if current start and maybe, yeah, we want to make sure it is equals to the current character. We want to go till that end, and we will be incrementing it. And same thing we can write here, but instead we want to move from the right end to here. Just wait a minute, I'll be explaining what I'm trying to do. So there are two inner conditions that I have written. The outer one loop is just to make sure that the characters in the both of them are equal if these conditions have been reached out, and the inner one makes sure that we consider in the prefix all the equal characters. We don't miss any character to achieve the minimal condition that we have. So you might be thinking like here we have not written equal, like, but we have here mentioned. So it's just assume we start with the current start, like we suppose in the string there are all elements equal, like a, and you start with the start one, and like you just go till the end. So if you have already considered that condition current start there, that is already updated here in the next while loop. So this makes us sure that we are not repeating the operations again. So yes, I think that would be it. So we, in this inner loop, we are making sure if it matches the character. In the below loop, we are moving from right to the left direction and making sure the characters are equal. And yeah, and every character in this, as you see, is traversed only once. Once we have incremented, we are not going with that character again. So if there are n elements in a string and with we are going through every character once, can you guess the time complexity? Yeah, I'm not sure like if you could guess it, but I would mention it's O of n, because yeah, we are just traversing that element only once, so it's n length and O of n. So I think this should work if I have not missed any, or if there is no typo error. Yeah, I mentioned if there is no typo error. Okay. Okay. Yeah, here it should be, it's not assignment, it should be equal operator. Since it's accepted, let's check for the final check. Okay, I got a streak. Yeah, it's accepted, and runtime is 3 milliseconds, beats 100% of users with Java. Interesting. I think maybe this solution may be improved because of one condition that I didn't took into account was there are only 3 characters A, B, and C. Maybe you can tell me in comments like why this information was given, and I would be really interested to follow up on that. But yeah, for this video, I think that's all. We have figured the time complexity, that is O of n, and in space we are not storing any array or anything or any string. We are, so its space complexity is O of 1 and time complexity of O of n, and our solution is great. And I think you got the way in which you should be thinking in these kinds of problem. If not, just continue in my Leetcode series and you will be able to get with different kinds of problem that we'll be tackling in this series. And yeah, that's all for this video. Don't forget to subscribe to my Sing Dive in the Insights channel and turn on that notification bell to receive notification for my this series and the another playlist that I'll be bringing in this channel. Yeah, that's all for this video.